Hello everyone, welcome back to the Code Syndicate. Today we will be continuing type conversion of Rust integers. Till now we have seen type conversion between unsigned integers type of different sizes. If you can recall, we have also seen type conversion of signed integers to unsigned integers and vice versa. But that was between the same size integers like i8 to u8 or otherwise. Today we will see how to convert types between two signed integer of different memory size like i8 to i16 or vice versa, and what happens behind the scene for this type of operations. Before we begin, I noticed people are watching my videos but I didn't have any response in the comment section. If you guys feel you are learning something from my videos, please comment down below. If you have any feedback or suggestion, please feel free to convey me in the comment section. Now, let's get back to the topic. First, let's declare a i8 type variable and later we will convert this to i16 type. For this, let num type will be i8 equals, let's say, 70. Now convert this number to i16 type. Let converted num type will be i16 equals num as i16. Print the output in the console. Now open the terminal and run the code. Cargo run. We got 70 as the output. Now, before we go to the explanation part, you should first know how signed integers are stored in the memory. If you are following this series from beginning, you should probably know how signed integers are stored in the memory. If you are first time viewer, I recommend you to watch this series from beginning or at least the video in which I discussed how signed and unsigned both the data types are stored in the memory. I will put the link in the description below. Now I assume you know the concept of two's complement rule, which is used to store the signed integers in the memory. Now first let's see how number 70 is represented in binary. As you can see 70 in the binary format. It takes 7 bits to represent 70 in binary. Now, as the data type is i8, which means we have 8 bits or blocks to store this memory. But as you can recall, it is a signed data type and the leftmost block or the first block is reserved for sign indication. So out of the 8 bits, first bit is used as the sign indication. As the number is positive, we store 0 in the first block. In case of negative number, we use 1. And for the remaining block, we store 70 like this. Now, when we convert this number to i16 type, it just places the entire 8 bits to the right blocks of the 16-bit memory type. And in turn, when we obtain the number from memory, it checks the first bit, which is in this case is 0. So it treats it as positive number and converts all other bits to decimal, and which gives us the result 70. If you convert this binary, you will get 70 as an output. Next, let's see what if we replace 70 with minus 70. Change this 70 to minus 70 and run the code. In this case also, we are having a perfect conversion. But what happens behind the scene is interesting. Now, let's try to fill the 8 bits of memory blocks with minus 70. As the number is negative, the leftmost bit will hold 1. Now, as for negative number, instead of putting the binary representation of 70 in the remaining block, we find 2's complement for the 70, which we get this. When we convert this I8 to I16 type, the Rust compiler first checks the first bit, which is 1 in our case, which indicates a negative number. Now it shifts entire 8 bits to the right side of the new allocated memory of 16 bit and fills all the remaining blocks with ones. Now, when the program obtains decimal number from the above memory blocks, it checks for sign indication, which is negative as the first bit is 1. So it inverts all the bits, which becomes this, which equals 69, and finally adds 1 thereafter, which results to 70. As the number is negative, we say it is minus 70. That is it for today. Hope you understood the concept. If you have any doubt, comment down below. I will try to help you out. If you like the video, press that like button. It will help me a lot to be motivated to bring more such content. Thanks for watching, and I will see you in the next video.